Okay, let's say implicit type conversion in action. First, I declare a byte, call it B, and set it to 1. Now I declare an integer and set it to B. Again, to recap, a byte is only 1 byte and an integer is 4 bytes. So we can copy B to I without data loss. And as you see, there is no compile time error here. Let's put I on the console. So console.writeLine, and we pass I here. Note that as I typed console.writeLine, my ReSharper plugin automatically added this using system statement on the top. Again, if you don't have ReSharper, you need to go manually add this statement here. We run the application by Control and F5. So we got I on the console. Now let's reverse this and see what happens. So I'm going to get rid of this code here. Control X, Control X, Control X. First, I declare an integer, set it to 1. Then I declare a byte and try to copy I to B. We immediately got this red underline here. If you hover the mouse here, the tooltip says cannot convert source type int to target type byte. Sometimes this error might be in a different file which is not open in Visual Studio here. So you may see the error when compiling the application. Let's simulate that. So I compile this application by Control, Shift, and B, which stands for build. So here's the error. Cannot implicitly convert type int to byte. An explicit conversion exists. Are you missing a cast? So now you understand the concept of implicit versus explicit type conversion. So what we need to do here is to do a cast. So we cast that integer to a byte. Now in this case, no data loss will happen because the value is small enough to be stored in 1 byte. Let's put B on the console. Console.writeLine, B. We run the application. So everything is good. But let's see what happens if we set I to, let's say, 1000. We cannot store the number 1000 in a byte. The maximum we can store in a byte is 255. So if we run the application now, we got 232 because some of the bits were lost. And this is the reason that C# compiler knows that there is a chance for data loss, and it enforces you to explicitly specify the cast. Sometimes you know that despite the differences in data types, there is no chance of data loss, like in the last example where I was set to 1. In those cases, you can safely apply a cast. Okay, now let's take a look at non-compatible types. So let's clean up this code. I start by declaring a string. Let's call it number and set it to 1, 2, 3, 4. Just recapping from the last lecture, note that here I could declare this with the var keyword. And C# compiler automatically detects that this is a string, so number will be defined as a string. And we can see that by hovering the mouse here, it says system.string. Now let's say we want to convert that to a number. If I declare an integer, like I cannot cast that number to an integer because they're not compatible. Let's take a look at the error. Cannot cast expression of type string to type int. So if you see that error, that's the time when you need to use the convert class. So we type in convert dot. Take a look at these methods here. To byte, to char, to int16, to int32, and many other methods here. So let's convert that to an integer, which is int32, and pass number as an argument here. Now let's print out the I on the console. Run the application. So I is 1, 2, 3, 4, all good. But let's see what happens if instead I declare this as a byte. And here we need to use convert.toByte. And here we display B on the console. A byte does not have enough storage to store the value of 1234. So when we run the application now, the application crashed. We cancel this here. And here's the exception. Exception is .NET Framework's error reporting mechanism. It's an advanced topic, and I have covered it in detail in my C# Advanced course. But in this video, I will briefly show you how to handle exceptions. So here it says on handle exception, the type of exception is system.overflow exception, which means we try to store a value that was too large or too small for a byte. So each exception or error has a type, in this case overflow exception, and has a message. Value was either too large or too small for an unsigned byte. Sometimes the exception messages are friendly enough that are easy to understand. Sometimes they're a little bit tricky, and the best way to work out what is going wrong is to jump on Google and search for the error, and there's pretty much always a Stack Overflow page that explains that. Now let's discard that. Let's see how to handle the exception here. So the exception happened during conversion of that string to byte. What we need to do here is to wrap these few statements with a try-catch block. Let's see how it works. So I just typed try and pressed enter, and Visual Studio automatically generated this block for me. Again, this is what we call a code snippet. Let me undo this and show you one more time. So try, see this try here in the IntelliSense, and this icon represents a code snippet. So if I press enter or tab, you automatically get this code block. So what I'm going to do now is to move this code into the try block, and the catch block gets an exception. By default, Visual Studio has this throw here. Don't worry about it, just delete it. Again, I will explain it in detail in my C# Advanced course. For now, let's see what's going on here. So the code that you put inside the try block will be somehow monitored, and if an exception happens, this block will be executed. This prevents your application from crashing. The reason our application crashed earlier was because we did not handle the exception. So if you don't handle the exception will be propagated to the .NET runtime, and .NET runtime's mechanism is to stop your application and display the error. Here we can handle the exception, and that would prevent the exception from being propagated to .NET runtime. So instead we can display a friendly message to the user, saying, for example, console.writeLine, the number could not be converted to a byte. Now let's run the application again. See, we got the friendly message and the application didn't crash. So what I want you to take away from this lecture is this convert class works pretty well in most cases, but in cases where the source type cannot be converted to the target type, there is a chance for exception, and you need to be aware of that. And what you need to do is to wrap this block of code with try-catch. Let's take a look at one more example before we finish this lecture. Let's remove this, and instead define a string, call it str, and set it to true. We can use the convert class to convert that value to a boolean. So bool b equals convert.toBoolean, and we pass that str here. Again, in this example, string and bool are not compatible, and that's why we cannot use explicit casting. So here we are using the convert class. We can display b on the console. Let's run the application. So the true string was successfully converted to a boolean value. Okay, that's pretty much it for this lecture. Before I finish, I just need to emphasize something here, that throughout this course, during early lectures, you may see me using some short variable names like b or str here. That's purely for demonstration and keeping things simple. And in building real-world applications, we should really avoid naming our variables a, b, c, str. It's not really a good practice. The only exception is when we get to loops, which you will see later in this course. In for loops, we use counter variables and we call them I or j. It's a common convention. Now here we are just starting to learn C#, and it's really impossible for me to demonstrate building a real-world application because we're just covering the basics or alphabets. I hope you enjoyed this lecture, and thank you for watching.